We live in a time of global transformation. The Energy Futures podcast explores how we can accelerate the expansion of clean energy technologies and reduce our reliance on fossil fuels. From heating and cooling our homes to moving around our planet and beyond, we bring together researchers, scientists, business leaders and communicators to exchange knowledge and try to answer one important question. How can we create a sustainable energy future for all? This podcast is produced by Energy Futures Lab of Imperial College London.
To reach net zero, we need to electrify transport, from personal vehicles to heavy goods trucks. Welcome to today's episode. I'm Edoardo Taricco, a mechanical engineer and recent graduate of the MSc in Sustainable Energy Futures program at Imperial College London. Today, we dive into the challenges and opportunities of transitioning to an electrified transport system. Our first guest is Gregory Offer, a leading researcher in electromechanical science and engineering at Imperial College London. Based in the Department of Mechanical Engineering, Greg's work spans battery, fuel cell, and supercapacitor technologies, with a particular focus on their applications in transport. I'm also joined by Jade Edwards, Head of Insights at Zapmap, a leading source of EV charging data and analysis. With over a decade of experience in the data and insights industry, Jade's team delivers expert analysis on the state of EV charging infrastructure, driver behavior, and emerging trends in the EV space. Together, we explore the evolving EV market, examining trends in operating policies and their role in shaping global adoption, consumer behavior and its influence on the transition to electric vehicles, and innovations and challenges in charging infrastructure, including accessibility and user experience. Hi there, and welcome back to the Energy Futures podcast. My name is Edoardo Taricco, and today I'm joined by two wonderful guests. We're going to be talking about electric vehicles. So I'll get the two guests to introduce themselves. We'll start with Jade.
Hi Ed. I'm Jade. I'm Head of Insights at Zapmap, and we are the leading electric vehicle charging aggregator app in the UK.
Thank you. And Greg?
I'm a professor here at Imperial College London. I'm an electrochemist, but I'm based in mechanical engineering and run a large group that mostly works on batteries.
Great, thank you very much. So electric vehicles is not a niche topic. It's a guarantee that the automotive industry is going to move this way. Automakers have already decided that the drivetrain of the future is going to be electric. Policy and regulation have a big influence on this. But what this means is this is not a passing fad. These products are going to keep getting better and better and more appealing to consumers over time. So given that this shift to EVs is not a question of if, but of when, what do you see as the biggest opportunities in making electric vehicles not just a choice, but a preferred choice for consumers? And perhaps we'll start with you, Jade.
Yeah, so I think what we've seen so far with the 2 to 3% of cars that are on the road at the moment being electric vehicles is that the majority of people driving those cars are early adopters. And we do a big survey, nearly 4,000 responses from electric vehicle drivers that use Zapmap. And from that, 87% of those respondents are male. So at the moment, it's very much older, wealthy men who are the main drivers of or main owners of electric vehicles. And I think the opportunity is as we start moving into that early majority, that really opens up and you start having a much wider variety of drivers who are really getting the benefits from electric vehicles. But we've really got to sell that to people that may not be as interested in cars as these early adopters or as interested in new technology. They just want a car, a great car that's a brilliant lifestyle choice and that helps them be greener.
Thank you. Greg, your thoughts?
Yeah, I would agree. I mean, we in my group, we work on the science. We're trying to make the batteries cheaper, better, developing the knowledge that the engineers can use to design better products around. But ultimately, the consumer is, friends that I know who've bought electric vehicles, they didn't buy them because they're electric. They bought them because of various incentives, company car tax credits, things like this. Ultimately, the majority of people just want a thing that they can drive around in and move them from A to B. So I think that although those of us who work at the cutting edge, we keep talking about technology transitions and new technologies and all this kind of stuff. I mean, at the end of the day, the car companies are in a difficult position because they just have to make products that people want, and they. And so marketing the product as an EV works for the early adopters, but it won't work for the majority.
Right. And I think a thing to consider is the fact that a car is quite a personal item. I have a car, and unfortunately it's not an electric vehicle, but it's quite a personal thing to me. And I think that when you make the transition from an internal combustion engine car to an electric vehicle, I think you're changing from a system that you're very accustomed to one that's perhaps completely new. Having said that, I've spoken to people who have electric vehicles, and they don't seem to be the ones who have the range anxiety that internal combustion engine car owners perhaps do have. So what do you think about the transition to an electric vehicle as an internal combustion engine owner? Do you think that it's a big paradigm shift? What are your thoughts on that? Perhaps Jade, go first.
I think it's a different way of thinking and a different way of operating. You're so used to in an ICE car, an internal combustion engine car, you have to go to a petrol station, you have to fill up, and that's what you do. That's how you refuel this vehicle. But with an electric car, you've got so many more options, and so it's about understanding that. We see at the moment about 80% of EV drivers have got a driveway and are charging at home. So they're doing the vast majority of their charging overnight, plugging the car in like you'd plug your phone in. Everyone is used to that now with their electrical items. You plug them in, you leave them overnight, they charge. So it's a very different mindset. You're then only really, for that proportion of drivers, thinking about charging publicly when you're going on a long journey. And that just at the moment just takes a little bit of planning, thinking through where are the places you might want to stop, and then planning that into your journey. And there's some amazing options now around the UK for that kind of en route charging. But there's just lots and lots of different ways and different solutions for charging, which is just not the same as refueling a petrol car, where you have to go to you can't fuel it at home. You've got to go to a petrol station.
And just to challenge that a little bit, do you think that that's the same in urban conditions and in rural conditions? Because perhaps it's more difficult to have home charging in rural areas where perhaps grid installation is more difficult, or you don't have the same accessibility to all these products. Do you think that there's much of a difference in this change in lifestyle for people who live in rural and urban areas?
I think it depends on your particular circumstances. So actually, in rural areas, there's a lot of properties which have got driveways, and you're only needing a home supply, home energy supply to be able to charge your vehicle. You don't necessarily need extra grid connections for that, or any extra capacity. Where it's obviously different is then if you're not going to charge at home, what are your options then? And things like supermarkets, Sainsbury's last year, they've rolled out banks of these ultra rapid chargers, which are the ones that can charge your car, give you 100 miles of range in about 15 minutes. They've rolled out banks of those at 60 or more stores just in the last year. So you've got these supermarket options. There's lots of work going on by local authorities to look at car park options. So on public car parks, on-street options, converting lampposts. BT are doing a big project to look at converting the green boxes. So there's lots and lots of different solutions, and I don't think it's necessarily a rural-urban thing. It's about what are your needs? Are you someone that just drives to and from school and to and from the shops, and you commute locally to work? That's, one use case where you're only going to have to charge once every few weeks, versus if you're a high mileage driver up and down the motorways. You might live rurally, but you're constantly passing these huge hubs on the motorways, and that's where you're getting your charge.
And Greg, do you think there's much of a lifestyle change switching to an EV? What are your thoughts?
No. quite simply. I think it very much is enabled if you have the off-street parking. So I do. So having an EV, I have one, and it's easy. There's, I'd say, there's only positives. For me, I think, you're absolutely right, Jade. In rural areas, you're likely to have a drive because there's more land, and a 30 amp domestic connection, which you need for your electric cooker anyway, is more than sufficient to charge your car overnight. Urban is the challenge because if you've got people living in blocks of flats, they don't have anywhere necessarily to park a vehicle, and that's the challenge. But for me, I mean, my first EV was a plug-in hybrid, and we had that just before the fuel sort of crisis, the mini fuel crisis that happened just after COVID, when all the supply chains were disruptive. And I must say with a huge amount of smugness that it was immensely satisfying to watch all these people queuing up outside petrol stations and just to be able to plug in and just let my car charge itself overnight for a fraction of the price. So that was a huge positive. I've now got a full EV as well, which is just used, as Jade said, as a general runaround. So we just charge it overnight, and it costs us 1 or 2p per mile to run, compared to 15-20p per mile, which would be a combustion engine vehicle. Again, that's hugely satisfying, and the experience of driving that car is, I mean, it's just a little Nissan Leaf, so it's sort of at the lower end of the performance specification, but I can beat any combustion engine vehicle at the lights. Just because it accelerates, because you've got that instant torque. So, just driving around a small town or city, it's great fun. So there's only positives for me. But I think if I lived in a flat in the middle of a city, then there would be challenges. And I think that's what we need to think of as the vehicles get rolled out to everybody. And they also need to be cheap enough for everybody. That's the thing. But I mean, we're seeing a lot of the Chinese imports are actually extremely cheap. They have they've got some very credible products that are quite attractive. So I think it's the transition is going to be happening a lot faster than people believed 10 years ago, even 5 years ago. I think the transition is going to go a lot faster than most people think.
I can take you up on that challenge. My Audi is small, but it packs a punch. No, I'm kidding. But do you think that, to what extent can you take advantage of certain things by having an electric vehicle that you couldn't by having an internal combustion engine car? Because I look at examples like Norway that have rolled out electric vehicles very successfully, and I know that they provide usage of bus lanes and free parking and stuff like that. So what kind of things do you see yourself making use of, conveniences, by having an electric vehicle?
So I wouldn't actually focus on them, because I mean those are going to change. In a few years' time they're going to have to tax electric vehicles in some way, so that the income in terms of at the moment, the combustion engine vehicles are taxed heavily, and you've got tax breaks for electric vehicles in terms of, the electricity that you charge isn't taxed in the way that fuel is taxed so heavily. And of course, in a decade's time, hopefully, much more than 1 or 2% of vehicles are electric, and then the treasury is going to be upset, and the same is going to be true of other countries. So those tax breaks, those incentives are not going to stay forever. So I'm more interested in the long run. How do we create a sustainable transport system based around these new technologies, where ultimately they're going to have to pay their way, they're going to have to be part of a system. So then looking at what are the benefits of EVs in the long run, they enable you to achieve renewable electricity penetration on the grid approaching 100%, which otherwise would be very, very challenging, very, economically very challenging. Because as soon as you've got millions of electric vehicles plugged into the grid, and considering that the utilization factor, how often a vehicle is driven, is about is between 3 and 5%, depending upon which country you're in. Most of the time they're sat there doing nothing. So if they're plugged in, then they're a massive battery. If you aggregate 1 million vehicles, that is equivalent to, a huge power station. So you can do amazing things at the system level when you have large numbers of electric vehicles. Now you need the infrastructure to do that. You need bi-directional charging circuits so that the vehicle can actually put power back into the grid, if the grid needs it. And you need new business models. You need economic incentives. You've got to pay me a bit of money to be able to draw down on my battery because, that's going to degrade it slightly. So I need to see a return. So I think over the next decade or two, there's going to be hugely interesting new business models emerging. I think the innovation that we've seen so far is just a fraction of what is going to happen.
You've touched on a much larger talking point there. But Jade, do you want to weigh in?
I was just going to say one of my favourite little sayings that I heard someone say at a conference was about the fact that if you think about EVs, they're just batteries on wheels. Millions and millions of batteries on wheels, and that is going to be that's the transformational piece, really, is once you've got that bi-directional capability across more and more vehicles, you've got your what we see in our surveys and with our users is that EVs are a little bit like a gateway to more kind of renewable tech. So the percentage of people that have got solar panels or heat pumps that have an EV is much higher than just the general population. And so you start to see how this all feeds in together. So they're drawing down from the solar panels into the EV and storing the energy when it's not being used and it's cheap and it's completely renewable. Then when that energy is needed later in the home, you could be discharging that energy into the home or discharging it back to the grid. So there's just so much flexibility that can be introduced in future. And I think that's the really, really exciting piece.
Yeah, I would agree.
Have we seen many success stories in that field of vehicle to grid so far in the UK or elsewhere?
I think it's in its infancy at the moment. One of the areas that a colleague in the industry is really excited about is bin lorries. Because bin lorries are used in the early mornings and then they're sat around. And so actually you could be charging their batteries and then using them to charge other vehicles and things at different times. They're not going to use all the charge they've got from doing that round. So it's things like that, I think, where we will really start to see those success stories as the fleets start to think more cleverly about what they can do with their vehicles and how are they going to manage this.
Have you got any thoughts, Greg?
Yeah, I mean, I actually had a master's student on the Sustainable Energy Futures course about 8 or 9 years ago who did a project on looking at the costs at the grid scale, in a future scenario, 20 years into the future or thereabouts. And if you had 1 million vehicles, actually the power they could provide to the grid is not necessarily the size of the battery, it's the size of the connection. And if you've got a 30 amp, 7 kilowatts, if you've got 1 million vehicles, you've got 7 gigawatts of virtual power station. Now if you offer that to the national grid and say, okay, here's a distributed power station that you can use, when there's a peak of power demands at the different points of the day, and then you say, okay, well, what would be the alternative of providing those peaks? It would be build an extra 5 power stations. And so the saving is actually of that magnitude. It's like saving billions and billions of pounds of not having to make these power stations that are called spinning reserve, that they're just there for a few hours of every day just to provide the peaks. And so at the system level, that's the magnitude of the economic benefit. And then how do you share those spoils? Pay some to the vehicle owners to offset using their asset for this purpose. And then the rest is profit to be distributed to other people via some new business model. So that hasn't been done yet, but you can see from an engineering point of view that is eminently possible. and wouldn't require, smart meters open the door for that, and then you just need to upgrade the wall chargers on people's houses to allow power to flow in both directions, and then you can do it already.
Is there not a worry that with these bidirectional chargers, when you increase the charging and discharging cycles of these batteries in a vehicle-to-grid system, to what extent will the degradation of the battery really damage its value?
Like I said, you'd need to offer an economic incentive to the customer that is going to offset that, that slightly faster degradation. But if you pay me more than the value is decreasing by, then I'm happy.
Makes
as
sense.
A customer. So I think it all comes down to a business model.
And is wireless charging something that is on the horizon? Is that still a bit too out there?
I think so. Yes, wireless charging is one of those options. I think I see it as a spectrum. The cheapest charging is to just plug it in at home overnight. You can negotiate very low rates of electricity with your supplier, and there's most electricity suppliers will offer you a type of contract where you've got cheap electricity overnight, and you don't need much infrastructure. The next level is as Jade was mentioning, forecourts of supermarkets where you've got faster charging. That costs more money, so that's an infrastructure cost, a capital cost. So you need those chargers to be in use most of the time in order to justify that investment. Inductive charging is sort of like more expensive again. You've actually got to dig the road up and embed these under the road or under the car park surface. So you're unlikely to do that in a domestic situation where you're only going to use that for low current charging, overnight. You'd have to be a very wealthy person to the economic return is not there in that application. So I'd say that's more going to happen in commercial applications where where there's a particular business model. So there's a spectrum of charging solutions depending upon that ratio of how often is it going to be used versus the capital investment.
Right. Jade, would you like to weigh in?
I don't think there's much more to add on that one, really. It's not something that we see, at the moment, really. So at the moment, there's nearly 73,000 charging devices out on the public network, but that is people plugging those in to the cars and charging in that way. So I think, Greg's absolutely right. It's going to be it's just an extension of the spectrum we already see. And I think it will be for very, very high throughput, where people are willing to pay for convenience at an even higher rate. And that's where you'll see that kind of start to come into that spectrum.
Like a taxi rank at a train station, because the taxi drivers are going to, sit there sometimes for 30 seconds, sometimes for 30 minutes. In the space, if they're just there for a couple of minutes, then the time it would take to plug in and, it would be too much hassle. So if you just had a rank with a row of inductive chargers, then that would probably pay for itself. So, yeah, it's just horses for courses, basically.
And there's a lot to unpack around charging infrastructure for electric vehicles. And I guess there are many challenges associated. And it's, I guess, one of the things that needs to go hand in hand with increased EV ownership if we are to decarbonize transport. So Jade, what are the main barriers to implementing and installing more charging stations in the UK?
Yeah, so at the moment, it depends on which type of charging solution, for one. So if you're looking at the more low-powered end, then actually a lot of that is being supported by the government's local EV infrastructure funding, so LEVI funding. So £450 million has been allocated across all the local authorities, and they are now working through their procurements to actually work out what solution they need, and that will be about that low powered charging, and it's about the equity for that, the equity of the transition. So making sure that those chargers are going in where they will be needed and in areas that might not be as commercially attractive to a charge point operator who at the end of the day is generally investor backed, and they will need to show a return to those investors at some point. So that's the kind of the lower powered end of things is being funded, and there's lots and lots of work going on there, but we probably won't see those chargers going in the ground until next year, the following year. So that's that side of things. On the higher powered end, there's lots of private investment into that, and the charge point operators are it's a land grab, so they're all trying to get the best sites to put their high-powered hubs of chargers in. The difficulty they often face is about grid connections and going through that process or planning processes. So it's more kind of red tape issues that they face once they've selected sites and they know where they want to put them. That can be the thing that actually takes them more time to get those through. But there's lots and lots of private money in that side. And so those charge point operators are absolutely gunning to get as much stuff out there as possible at the moment.
So there are bureaucratic issues around securing grid connections. Is that something that you see is going to get better over time, or is that just something that? Yeah,
definitely. And the government and all the DSOs, the operators, they're trying to work together to actually remove this as much red tape as they can, make these processes more straightforward. But one of the things that I think people, when they see these kind of banks of chargers, if they see them at one of the petrol stations or something, you see, a bank of 6 of these chargers. They're just like fairly small little boxes in the corner of a forecourt. Actually, to put one of those in and switch that on is like switching on the Shard. So you wouldn't just expect to just plonk the Shard down and go, yeah, let's go. The grid's going to cope with just putting that there right now. It's about planning. It's about working out where they need to reinforce, how they need to do it. There's enough capacity within the grid to be able to provide all the energy. It's about that reinforcement and that restructuring and putting things where it needs to be.
Jade, do you think, this is a provocative question, do you think there's a risk of at least local monopolies forming? Because if it's a land grab and a power connection grab, then when one company has all the power connections in one area, they have a local monopoly.
I think on the high powered, it's actually, what we see is it's really evenly spread. You don't tend to see in one particular area just one charge point operator. They're mostly national coverage, and so you'll get within quite a small area, you might have a Sainsbury's with a smart charge. You might then have an Osprey at one of the pubs or a farm shop that's around the area. And then you could have an Instavolt as well. So it's certainly not, we just don't see it's all in one area for any particular charge point operator. They are really well spread at the moment. Okay. On the low power side, it's the way the local authorities are trying to mitigate that. So it's about giving contracts, but making sure that you've not just given everything to one operator and then you have got a monopoly in with that particular one operator.
Yeah. Greg, I'd like to hear your thoughts about what kind of strategy is best for rolling out this charging infrastructure. What kind of chargers do you need to look at what kind of places, what times? Could you talk us through a bit more?
I mean, I'm probably much less qualified to answer that than Jade. I'd defer that question to her and answer something else.
So what type of charging infrastructure?
Yeah, what constitutes a strategy for rolling out charging infrastructure? Where is it best to find the DC fast chargers over the slow chargers, and location-wise, timing-wise? How do you roll out this infrastructure?
So it depends on each charge point operator's particular business model, really. So some are looking for sites that are near the strategic road network, so not necessarily on the motorway, but along the A roads and with easy access from motorway junctions. And there they're looking for sites where they can provide facilities as well as charging. So you have that kind of model. Others are really focused on the on-street model. So they're looking at putting lots and lots and lots of lower powered chargers across the streets of more urban areas so that people can park pretty much outside their home where they would normally park if they didn't have a driveway. They can park there and they can charge. So you've got those two kind of different models, and then you've got the destination model, which is either short stay destinations like supermarkets. So there you might put higher powered devices in so people can stop for a short amount of time, top up and go and purchase something from that kind of retail destination. Or long stay destinations where people might be going, so National Trust places, if they're going to Alton Towers, things like that, where people are going and they're going to stay at that destination for a long time, or hotels staying overnight, and then you'll have that lower powered charging because they know people are going to be able to plug in and connect for 3, 4, 5, 6, 7 hours. So there's just lots and lots of different business models, and the different charge point operators are then working with the different businesses that offer the facilities often to try and marry those up and get a good fit and a good match between their land and what the charge point operators can offer.
And in the UK, to what extent are things standardized so that if I want to one day use a slow charger, say on a street, and then I want to use another fast charger in a completely different location, is it the same sort of plug? Can I use both just as easily?
Yeah, so it depends on your vehicle. Most of the vehicles, not the Nissan Leaf, that are out there today have a CCS charger for the sort of fast, rapid charging. The Leafs have what's called a CHAdeMO charger. So there's much more infrastructure for CCS out there at the moment. And then there's Type 2, which is for the slower charging. So there's lots and lots of infrastructure that covers all these different options. So you need to know with your car what type of chargers can your car use. And that's something we do on Zapmap, is you put in your vehicle when you register, and then we will show you the charge points that you can use. So there's that side of it, which I think that's kind of been consolidating into CCS becoming the standard in the UK. The other side of it is actually about how do you use these chargers. So the government have put some legislation out called the Public Charge Point Regulations. And one of the things they've put within there is that in the next year, all charge point operators have to roam with at least one roaming partner. And that means they have to allow you to pay and use their chargers through an aggregator. So like Zapmap, we offer a service called ZapPay. There's other aggregators out there that do that same service. And so what it's trying to do is make sure that EV drivers don't have to have a plethora of different apps on their phone in order to use all these different charge point operators. They can roam and pay with using a handful of aggregators. And then there's also legislation about contactless. So anything over 8 kilowatts, so basically anything over the slowest chargers, is going to have contactless to enable you to just tap and pay when you turn up at a charger. So there's lots and lots of thought going in the industry to how to make it easier, because early adopters were not necessarily always happy to have all these apps, but were more inclined to do it and to make the investment in time and to, enjoy all the technicalities. Whereas the mainstream majority are just not going to be interested in that. They just want a simple experience, and contactless or having some roaming providers that offer other benefits are what they're going to go for.
Yeah, I think the average person is not going to want any apps. They're going to want just, well, surely I pay with everything else contactless. I just turn up, plug in, contactless, done. And that's where ultimately we need to end up.
Yeah. And the legislation's been is really good for that. So it's really, the government have really been pushing that through.
I would say the killer functionality that would justify having an app, in my mind, is the ability to book a charger in advance. Mm-hmm. So if you're doing a long distance journey, you're going to have to break and have half an hour to recharge. And okay, you can have a tea or a coffee, but you don't want to have to then sit waiting for an hour in a queue and then add the half hour on top. So yeah, contactless and booking in advance, I'd say, are the two things that would make it seamless for the majority.
I remember when, and correct me if I'm wrong, when the Nissan Leaf first came out, it had some problems in extreme cold. problems regarding the battery and its longevity. Do charging stations also suffer from similar problems in extreme temperatures, or is that not so much a problem?
No. I would say the problems with the Nissan Leaf were not unique to the Nissan Leaf. There were, all of the early generation EVs had challenges associated either with the chemistry or with the design of the system. So the first generation Nissan Leafs didn't have a very advanced thermal management system, so they couldn't. Cold reduced the range significantly. It was the high temperatures that caused the high degradation. They're so much better now. There's no problems basically for the average person. I know how to make that battery pack degrade fast if I want to, but that's because I understand the science. But the chargers are just a bunch of power electronics. There's no chemistry in there to degrade. Yes, electronic components can degrade as well, but but they are a tried and tested, a proven technology. It's easy to write a specification for a charger that can operate at -10 and up to +40. So no, the problem with fast charging when cold is the battery pack itself can't accept that current at those rates when it's cold. You've got to let it warm up basically. So I suppose if you have a load of customers turning up with cold batteries, then your queues might get longer because they have to take a bit longer to charge because everything's cold. But it won't be because of the chargers themselves.
So how do you design a battery pack such that it is less prone to degradation? Because I know that so there's thermal management systems, but then the size of the battery, I know that compared to Tesla's, for example, the Nissan Leaf had larger modules. Walk us through the science behind that.
So we are yet to see any convergence in terms of everybody adopting the same type of battery, the same type of form factor. Everyone is still making their own packs their own ways. There's a little bit of convergence in that, you've got broadly two big camps. You've got those who use smaller cylindrical cells and those who are going towards much larger prismatics, sometimes pouch. There are advantages and disadvantages of both. The smaller the unit cell, the smaller the cell, it means that if one cell does go pop, then the amount of energy is limited and it's easy to handle. Whereas the bigger cells, their advantage is that you've got much less additional mass in the battery pack, and much less additional volume, so you can achieve much higher space efficiencies, so you can have smaller, lighter packs. It's where most of the Chinese manufacturers are going. They have very advanced cell-to-pack and even cell-to-vehicle concepts. And that also drives the cost down. So that's why they can offer EVs 30% cheaper than their competitors. But it all comes down to thermal management, and it all comes down to good system design, which is essentially a systems engineering problem. Love him or hate him, in the electric vehicle space, one of the most significant and influential people over the last decade has been Elon Musk. And ignoring the politics, let's not go into that. Whether you love him or hate him is up to you. But in terms of his approach to innovation and engineering, it's phenomenal. And in his other ventures, SpaceX, he was famous for really doubling down on this systems engineering way of thinking and saying that the biggest problem with most products is that different divisions, different sort of disciplines who focus on designing their bit of the system fall into subsystem optimization traps. And we have definitely seen as a result of some of our research that cell designers, most of them, in the past fell into a subsystem optimization trap where they optimized the cell, but what they'd ended up doing was making a cell that it was very difficult to design a good battery pack around because you couldn't get the heat out of the cell very easily. So it made the systems engineers have to spend a lot more time and money and mass and volume on a thermal management system to get the heat out. Whereas some subtle changes in the cell, just sacrificing 1 or 2% of energy, you could increase the rate of heat rejection by an order of magnitude, which meant at the system level, you could design a much simpler and cheaper battery pack. So that two of the most significant advances over the last decade were the tabless cylindrical cell from Tesla and the blade cell, the huge prismatic cells that BYD pioneered. They are the two most significant engineering breakthroughs of the last decade in lithium-ion batteries, and both of them are so significant because they were driven by their systems engineering thinking. They were trying to ultimately design a better battery pack, not a better battery cell. So the innovation in cell design came about through trying to design a better battery pack. So they made a slightly worse cell, you could argue, but it meant you could have a better battery pack.
To what extent do you think regulation sometimes blocks creativity and innovation? Because I know that Elon Musk, one of the things he really doubles down on is challenging every rule. You know, do you need 4 screws? Can you do it with 3? He challenges everything, and I think that was a big part of Tesla's success. To what extent do you think sometimes creativity and innovation is blocked by whether it be regulation or part dependency?
I wouldn't say innovation in batteries is blocked at the moment. The technology is moving too fast for regulation, or I'd say in this case, I would probably replace the word with standards. So standards, if sometimes an industry partner will use standards as a way of making their product, compulsory, in essence, or preventing a competitor from competing. But I haven't seen any of that happening. I mean, basically, batteries are just changing so much that the standards can barely keep up. And so, really, I don't see it as a problem until batteries become the incumbent, and then things will start to become standardized. But then the positives of standardization is it drives the costs out. So yeah, I don't see much evidence for innovation being stifled at the moment.
Is there much spillover from grid-scale battery storage systems into those used for EVs? How closely do the two fields work together?
Interestingly, I'd say it's the other way around. So the automotive companies, the automotive application is driving the volumes. That is driving the investment, the building of the gigafactories. The short-term blip, that might last a few years in terms of the economics, in terms of the problems with Western automotive companies having economic problems right now of not quite selling enough vehicles, seeing the EV mandates coming in, they're not quite reaching those sales targets, and so they're worried about the fines, and therefore they're lobbying governments to water them down a little bit. There's a lot of noise in the system at the moment, which is making people think, maybe electric vehicles, are slowing down. They're not. The long-term trend is multi-decade transition, and this is just short-term noise. But the effect that is having on the system and how people are thinking is sort of like, making people think internal combustion engines are going to have a comeback, which they're not, in my opinion. But yeah, I think I'm digressing. What was the original question?
The original question was spillover between in the research. So grid scale.
So because of this slight slowdown in EVs, that they're still growing. They're just not growing as much as people thought. What we're seeing is that those gigafactories have been built, and they still need to make cells and sell them. So what they're doing is they're not dumping per se, but the costs are going down, and that additional capacity is being used to produce more batteries for grid storage. But a 10% reduction in batteries for EVs is sort of like doubling the number of cells going into grid storage. So it's almost like grid storage is there as a valve to absorb extra capacity when EV sales are a little bit sluggish, as a way to keep those gigafactories economically viable. So when EV sales go up, then the price of cells will go up, and then energy storage, grid scale storage, they'll wait a bit. So there's this I'd say symbiotic relationship between the two, which I think is actually quite useful.
That's very interesting. Jade, would you like to weigh in?
The only thing I was going to say on that, because I am not battery expert, that's definitely in Greg's wheelhouse, is that from an EV skeptic's perspective, I think the simplest message out of everything is that we are just at the start. We're at the cusp of what the battery innovation is going to be and what is going to happen to these batteries and how much more efficient they're going to get and how much more ethical the processes to produce them are going to get. We are just at the cusp of that. There is so much scope for what is going to change and innovate over the next 10, 20, 30 years, whereas the internal combustion engine, there's very little change that is going to happen to that because it's it's been through all these years and years and years of innovation to get it as efficient as they can get it, and it will there'll be incremental gains on that, whereas on batteries the scope is kind of endless at the moment. And what you illustrated that absolutely perfectly there with the detail about how that is changing.
And we're at the beginning. Typically technology transitions go through an S curve. You've got the start when it looks like it's going exponential. But nature abhors an exponential. You can't carry on growing infinitely. Eventually, something breaks. So eventually, you start to saturate, and then the percentage of EVs starts to tail off, and you end up plateauing at some steady state. So that S curve, we're not even halfway. We're not even at the steepest point of that S curve yet. We're still in the foothills of the mountains, and so all kinds of weird things are going to happen. All kinds of short-term panic. Sales go low. Everyone thinks, oh no, this is the end of it. No, that's and then then in a few years' time there'll be hype again, and it will go too fast, and then everyone and then the opposite will happen, and people will get overexcited, and that's going to continue to happen. And when the magnitude is low, the effect of those hype cycles, is large. And as the sales volumes grow and the industry becomes more mature, then the hype cycles dampen and look smaller, and people start going from one extreme to another. We don't suddenly get excited. People didn't think 20 years ago when there was a small sales dip in combustion engines that was the end of combustion engines, because the technology was mature. I also before this meeting I looked up an example that I shared with a friend a while ago. I like to learn from lessons from the past. There's a good example from the 1920s when combustion engines were taking off, and there was a great example in the west coast of the US for almost a year where, at that point in time, to draw an analogy with electric vehicle charging, where did you get petrol from? They'd only just started making gas stations. Typically you would buy your petrol in cans from pharmacists, from chemists, because they were used to dealing with, products, chemical products. That was where you went. And so the supply chains were still developing, and there were problems with them, and they didn't always work. And so, there was a different type of range anxiety, which is that, well, if I go to the chemist, will they even have any fuel? And so there was a period of time lasting about a year back in the 20s on the West Coast where there was an artificially created, because of various competition between companies. This wasn't a government. There was rationing of fuel by the oil companies without any government intervention or anything, because they were basically trying to keep prices low. And they kept prices low through rationing, bizarrely. And so there's all kinds of weird examples from the past, and you look back at them and you just think, yeah, it did not go smoothly. There was odd behavior, there was surges, there were dips, all kinds of stuff. And exactly the same is going to happen with EVs. And I think I have to operate, in the research environment with a long-term view. This transition is happening. We're in the foothills. The investment levels that have gone in means this is now inevitable. The global automotive industry and the battery industry together have invested, I think, probably trillions of dollars now in this transition. They cannot afford to invest in anything else. This is their bet. They don't have trillions more to invest in something else if EVs fail. So it will happen because they have to make it happen for their very existence.
I completely agree with both of you. I think that people often lose sight of the fact that this is still a new market, and because it's such a visible one, especially now with a lot of car brands going through these rebrands, but it's a sector that's still new, and we need to let technology play its course. So, Jade, a question for you. The rate of increase of EV ownership in comparison to the rate of supply of charging infrastructure, what does that look like? Are they kind of going hand in hand, or is one lagging behind?
Yeah. So we did a piece last year looking at the utilisation of charge points and actually how that was changing. And what we'd seen was that actually over the last year to 18 months, we weren't seeing huge increases in the percentage kind of utilisation of public charge points. And partly that looks like it is due to a bit of a balance of kind of supply and demand. So in terms of the rollout of the public charging infrastructure, as well as people converting to EVs, it's very difficult to come up with any kind of direct link on those things because the use cases and people's behaviours are so different. So you look at different areas, the spread of charge points across the UK, it's not all even. There's some areas where there's a much higher proportion of on-street slower charge points. So London, for example, that's where the majority of those kind of lamppost and bollard chargers are in the UK. They are in Greater London. And in the southeast, you've got a higher percentage of people that have got EVs than you might have in the northwest. So there's lots and lots of regional disparities. There's lots of different behavioural and use case kind of disparities. So it's really hard to try and use any of those really simple metrics of like number of EVs per population or number of charge points per population, number of charge point per EVs. They're all a little bit too simplistic to really see how that transition is moving. You do need to combine lots of data sources to actually start seeing that in a bit more detail. So we did a piece recently that's available online, which is with Vauxhall actually and Cenex, and it looked at different metrics for different use cases. So there's an online map where you can see actually the strategic road network and the coverage of those high-powered chargers that you would use en route along that network, along with the estimated volumes of traffic and various other things, all built together to give you a heat map of actually where does that coverage look like it's doing well at the moment, and what's that projection into the future. And then taking another use case was the near home one, so looking at that kind of low powered provision and the population and EV uptake and all these things together to kind of give different kind of heat maps, because it's too complex to boil it down to very, very straightforward sort of singular kind of metrics.
That makes sense. So if we step back a second and look at decarbonizing transport more generally, one thing, I read a very interesting statistic the other day about SUVs. They emit, in comparison to an average road car, about 20 to 25% more. And in the past 5-10 years, SUV sales has gone through the roof, especially in the US. And I read that if the expected sale of SUVs continues up until 2050, the additional negative impact that the sale of these big cars is going to have is more or less projected to counteract the positive impact that the projected sale of electric vehicles is going to have into the future. Do you think that there are other levers that we should be looking at together with electrifying transport cars that we should be looking at to really decarbonize transport?
Yeah, absolutely. I mean, the best solution is getting people out of cars altogether. That's not like that would be a better solution if we're not having to have single household cars. So looking at active transport as a number one preference where possible, shared public transport. All these options can help in that decarbonisation. And then you get to the kind of car clubs, because actually, we've said it before, how much time is each individual household's car sitting on a driveway doing nothing? But it's about the mix, and people want to have cars. They want their own personal car. That's still going to be, a big factor. So it's about can we get those cars to be electric, and can we get them to be smaller? And I think that's a transition that's going to be really interesting to see how that plays out over the next 10, 20, 30 years with a new generation coming through who maybe are more open to having smaller vehicles and recognise that they use them less. And I think, at the moment, the initial kind of set of electric vehicles that are out there are often those bigger, those higher value cars, because that's where the manufacturers know they can recoup their costs quickest. And they know that people that are wealthier are going to be people that are going to invest in something new more upfront. So that's what's come through first. But you're starting now to see those smaller vehicles coming out onto the market, lower priced. And once things start getting into the second-hand market, you're then really starting to see how that can kind of follow on and transition the whole kind of fleet. But it was always going to start with more expensive, bigger vehicles. That's just kind of the nature of the economics. But yeah, really, really important. Get people out of bigger cars into smaller cars. Get people out of cars if you can.
Yeah, I think the way I see it is that, our job in terms of doing the science is to create possibilities, create technologies which can be used, if they're used in the right way, to solve some of the problems that, our planet faces, that we face as a species. Electric vehicles on their own are not going to solve the problems if they're used wrongly. If we don't have, if we don't have sustainable supply chains for where we dig all the raw materials out of the earth, if we just replace, one environmental catastrophe with another, instead of burning fossil fuels and climate change, instead we just create, global waste mountains of spent lithium-ion batteries that are just slowly leaching toxic chemicals into the water supply. And, when we dig the stuff out the ground, we do it in the most unsustainable way possible. And if we use those batteries in bigger and bigger cars and generate our electricity by burning coal, then we've probably traded something bad with something worse. But if we make those batteries in a sustainable way, if we recycle the majority of the materials, if we swap out the dangerous and the toxic chemicals for safer versions, and if we, generate electricity with renewable electricity, and we pass sensible policies that sort of like incentivize appropriately sized vehicles for the application, then we'll be living in a much cleaner and safer and healthier world for everybody. So I think, thinking that technology on its own is going to solve all these problems is wrong thinking. And thinking that it's just as important to get the policymakers engaged, to get all of us, society, engaged in thinking, what kind of world do we want to live in the future? What kind of world do we want our children to be living in? And then make sure we agree a set of rules, that we all make, the compromises necessary in order for that to become a reality.
That's very interesting. I'd like to talk a little bit about heavy goods vehicles, because that's obviously a big part of decarbonizing transport as well. And I guess they pose their unique challenges. So could you talk us through the kind of technological and even infrastructural breakthroughs that are needed?
Yeah, I think heavy goods vehicles is super fascinating, because I've been to a couple of conferences over the last year or two where where people have presented sort of techno-economic analyses of heavy goods vehicles and considering, the mass of the battery pack and how much of the payload that displaces, etc. I think a lot of the assumptions, sometimes people who think they're knowledgeable present as a fait accompli, as a conclusion, you're never going to electrify heavy goods vehicles. It's implausible, it's impractical, it'll never work. They do some simple calculations, publish a report and think they've answered the question. But when you drill down, some of those analyses, some of those reports, even from a few years ago, were making wholly unrealistic assumptions. They were assuming that the battery packs would cost $200 per kilowatt hour. Well, you can get LFP cells from China for less than $50 per kilowatt hour. And the integration cost with a cell to pack concept maybe only bumps it up to $60 per kilowatt hour. There were reports from a decade ago that were saying the break-even point for, passenger EVs becoming cheaper than internal combustion engine vehicles on a total cost of ownership was somewhere between $100 and $150 per kilowatt hour. We're now down at 60. You translate those figures and you put that kind of cheap battery pack in a heavy goods vehicle. I've seen analysis which shows that it's both technologically and economically feasible, not just for the last mile delivery, but anything up to about 500 miles. So there is a possibility for a sort of like a Tesla effect, a disruption to how safe the incumbents think they are. I don't think that that's safe at all from disruption with electrification. I mean, super long distance, you're always going to have a place, but I think that place being safe is getting quite small for the incumbent.
So do you think that the battery technology that we have today and what it's kind of forecasted to be in the future is sufficient, or do you think that we're going to have to look at other technologies such as hydrogen?
No, the costs now are just so ridiculously cheap compared to what people thought. The costs people thought they would be now 10 years ago, they were totally wrong. Totally and utterly wrong. And so the economics of most of those analyses are out of date and wrong.
Jade, would you like to weigh in?
At the moment, we map the charging infrastructure that's out there that can be used by anybody publicly. We are getting more and more people having conversations in every industry conference that I go to now. There's at least part of that conference dedicated to talking about what's going to happen with heavy goods vehicles. How are we going to manage that? How are we going to get the charging infrastructure? So they're already out there and they are coming in greater numbers. So there's lots of investment, there's lots of projects going on to look at actually how do we serve that need on top of the consumer demand for charging. And there's lots of thinking around shared depots, so actually having chargers that are owned by one fleet, but they can be booked out and used by other fleets. So lots of sort of interoperability and sharing conversations to enable that transition. So I think, there's absolutely no doubt that is coming, and it is just that next big challenge along.
Thank you very much. I think we have to be wrapping up now. But just before we finish, could each of you say where our audience can find you? With Jade, perhaps you first.
Yeah, sure. So if you come over to our website, it is zap-map.com, and we've got lots of stats, guides, information on there for people in the industry, as well as for EV drivers themselves to come and find out about what we do and the information we share.
Thank you. Greg?
So you can look up our research group, Electrochemical Science and Engineering, on the Imperial College website, or look up my name and you'll find my personal webpage and contact details.
Great. Thank you very much. And one last thing from me, everything discussed today will be found in the show notes, so feel free to check those out. And just want to say thank you very much again to you both. It's been a great discussion, and thank you very much.
Thanks for having us.
Pleasure.
Thanks.
Thank you for tuning in to the Energy Futures podcast. Here at Energy Futures Lab, we are dedicated to addressing global energy challenges through pioneering research, innovation, and advocacy. To learn more about us and the exciting projects we are working on, visit our website and follow us on social media. If you enjoyed this episode, please like and share and subscribe to stay up to date with our latest content.